Hi, good morning, dear students. In the previous class, we learnt about basic proportionality theorem and three problems of exercise 2.2. Now, in this class, we are going to learn the remaining problems of exercise 2.2. Okay. In that fourth question, one small figure is given, that is figure 2.19. In that figure, DE is parallel to AC is given and DF is parallel to AE. We have to prove BF divided by FE equals to BE divided by AC. First, I will draw the diagram. One side, then so here the end points are B, A, C. BAC is one triangle, and in that it is given that D is parallel to AC. DE is parallel to AC. We have to draw one line. DE which is parallel to AC, and DF is parallel to AE. So this is AE line. We will draw this AE line, and DF is the another line which is parallel to AE. Okay, here DE is parallel to AC and DF which is parallel to AE. These are the given data. Okay, now based on this we have to prove BF divided by FE, that is equals to BE divided by EC. We have to prove. Okay, for that I will consider triangle ABE. Fourth one, consider triangle BAE. In this triangle, which are the two parallel lines? DF and AE are the two parallel lines. Here DF is parallel to AE. Then again we have to now apply Thales theorem. According to Thales theorem, so what it tells? It tells if a line which is parallel to one side of a triangle, then it cuts the other two sides in the equal ratio. So therefore, BA, this is one triangle, and here DF is parallel to AE. Therefore, we can write BD divided by DA, that is equals to BF divided by FE. We can write, okay, BD divided by DA, that is equals to BF divided by E. I will call this as equation number 1. Okay, this is according to Thales theorem or basic proportionality theorem. Next, in a similar manner, I will consider the triangle ABC, that bigger triangle. In the first case, I consider ABE, this triangle, and now I will consider triangle ABC. Consider triangle ABC. In ABC triangle, which are the two parallel lines? DE is parallel to AC. DE is parallel to AC. Now again we have to apply Thales theorem. According to Thales theorem, what it tells? BD divided by DA. Okay, BD divided by DA, that is equals to BE divided by EC, that is equals to BE divided by EC. So I will call this as equation number 2. In the second case, DE is parallel to AC, that's why it becomes BD divided by DA, that is equals to BE divided by EC. Now when we compare equation 1 and 2, see here left hand side BD divided by DA, here left hand side BD divided by DA. So both left hand side are equals to each other. Therefore according to axiom, if two things are equals to same thing, then that two things are equals to one another. So therefore comparing equation 1 and equation 2. So when we compare equation 1 and 2, it becomes BF divided by FE, that is the right hand side of first equation, that is equals to BE divided by EC, that is equals to B divided by EC. Hence prove. Okay, very simple problem. Only you have to remember the property of Thales theorem. How many of you understood this? Just comment your name and click on the like button fast. In this case, it is given that DE is parallel to AC and similarly DF is parallel to AE. First we have to consider triangle ABE. In triangle ABE, DF is parallel to AE. So that's why it becomes BD divided by DA, that is equals to BF divided by FE. Then in the second case, we have to consider triangle ABC. In triangle ABC, DE is parallel to AC. That's why it becomes BD divided by DA, that is equals to BE divided by EC. When we compare equation 1 and 2, because both the left hand side are equal, so it becomes BF divided by FE, that is equals to BE divided by EC. Okay, BF divided by FE, that is equals to BE divided by EC. So this is the solution of first problem. The next one, fifth problem. In the figure 2.20, so one figure is given, just I will draw that figure. You also try to draw the solve. Okay, one small triangle is present. Figure 2.20, and the endpoints are P, Q, R, and there is another line and one straight line, and also EF is another line. EF is another line, and next so this is point E, this is point F, this is point D, this is point O. Look at the figure correctly and read the question also correctly. Okay, now we have this problem in front of us. In the figure 2.20, that is this figure, DE is parallel to OQ. Okay, DE is parallel to OQ, and DF, that is parallel to OR. Now we have to show EF is parallel to QR. We have to show. Okay. So what are the given data? In this triangle, DE is parallel to OQ, that is given, and DF is parallel to OR, that is given. Now we have to prove EF is parallel to QR. Okay, for that first I will consider triangle POQ. Okay, I will consider this triangle POQ. consider triangle POQ. POQ. In this, which are the two parallel sides? DE is parallel to OQ. DE is parallel to OQ. This is the given. Now, when these two are parallel to each other, so then again we have to apply Thales theorem. According to Thales theorem, PE divided by EQ. Okay, PE divided by EQ, that is equals to PD divided by DU. PD divided by DU. See here, PE divided by EQ, that is equals to PD divided by DU, because DE is parallel to OQ. I'll call this as equation number 1. Now similarly, I'll consider the second triangle, that is triangle POR. Triangle POR. Consider triangle POR. In this, DF is parallel to OR. DF is parallel to OR. DF is parallel to OR. So again we have to apply Thales theorem. According to Thales theorem, what it becomes? PF divided by FR, that is equals to PD divided by DO. PF divided by FR, that is equals to PD divided by DO. How many of you understood up to the second equation? Comment your name fast. Okay, first we have to consider triangle POQ. In this, DE is parallel to OQ, that's why it becomes PE divided by EQ, that is equals to PD divided by DO. In the second triangle, that is triangle POR, DF is parallel to OR, so that's why it becomes PF divided by FR, that is equals to PD divided by DU. So this is the second equation. Now next step is we have to see the equation. Here in right hand side of the first equation is PD divided by DU, and right hand side of the second equation is PD divided by DU. So that's why these two left hand sides of the equations are same. So that's why when we compare equation 1 and 2, we'll get, so that's why I'll write compare equation 1 and equation 2. Compare equation 1 and equation 2. What it becomes? So both right hand side are same, that's why it becomes PE divided by EQ, that is equals to PF divided by FR. See here, PE divided by EQ, that is equals to PF divided by FR, when it is possible. So when and only EF is parallel to QR, this statement becomes true. So that's why by applying the converse of Thales theorem, we'll get PE divided by EQ, that is equals to PF divided by FR, in that EF is parallel to QR. Okay, therefore according to converse of Thales theorem, EF is parallel to QR. EF is parallel to QR. Okay, this is the solution of the second problem. How many of you understood this? Hence prove. Just look at the steps once again. First we have to consider the triangle which is present on the left hand side, then we have to consider the triangle which is present on the right hand side, and by applying the Thales theorem, and after comparing the equation 1 and 2, we will get by using converse of Thales theorem, we will get EF is parallel to QR. Okay, then sixth problem. In the sixth problem, it is given that in the figure 2.21. Okay, I'll continue the next problem. Problem number 6. In figure 2.21, first I will draw that figure. One triangle is present. You have to draw simultaneously and you have to solve also simultaneously. Second problem number 6. I'll mark the points. So this is point P, point A, point O, point B, point Q, point C, point R. Okay, this is the figure. So in this, it is given that in the figure ABC are points on OQ, points on OP, OQ and OR. That means A is a point on line OP, B is a point on line OQ, C is a point on line OR, and respectively such that AB is parallel to PQ and AC is parallel to PR. Okay, two conditions are given. AB is parallel to PQ and AC is parallel to PR. Now we have to prove BC is parallel to QR. We have to prove. Okay, we have to prove these two lines, line BC and QR are parallel to each other. That one we have to prove. Okay, for that we'll consider the left hand side triangle, that is triangle POQ. Consider triangle POQ. In triangle POQ, which are the two parallel sides? AB is parallel to PQ. AB is parallel to PQ. AB is parallel to PQ. Okay, then according to Thales theorem, what is the ratio? Comment me answer if possible. So in triangle POQ, line AB is parallel to PQ. Then we have to apply according to Thales theorem. According to Thales theorem, what it becomes? It becomes OA divided by AP. OA divided by AP, that is equals to OB divided by BQ. OB divided by BQ. So I will call this as equation number 1. OA divided by AP, that is equals to OB divided by BQ. Now we'll consider the second triangle that is present in the right hand side, that is triangle POR. Consider triangle POR. Triangle POR. In this, which are the two parallel lines? One is AC and another one is PR. So line AC is parallel to PR. AC is parallel to PR. So again we have to apply Thales theorem. According to Thales theorem, according to Thales theorem, what it becomes? OA divided by AP. OA divided by AP. See here, OA divided by AP, that is equals to OC divided by CR. OC divided by CR. So I will call this as equation number 2. How many of you understood up to equation number 2? Comment your name fast. So based on the ratios proportion or sides proportion, we have to solve the problems, that is by using Thales theorem, or that is also known as basic proportionality theorem. Okay, now by considering the left hand side of the triangle, that is triangle POQ, we got the relationship as OA divided by AP, that is equals to OB divided by BQ, and by considering the right hand side of the triangle, that is triangle POR, we got the relationship between the sides as OA divided by AP, that is equals to OC divided by CR. See here, left hand side of first equation, that is same as left hand side of the second equation. So that's why by now we have to compare equation 1 and 2. Compare equation 1 and equation 2, because in first and second equation the left hand side value is same. So that's why according to axiom, so we can write OB divided by BQ, that is equals to OC divided by CR. I'll write the reason as axiom. So here OB divided by BQ, that is equals to OC divided by CR. So in the figure, OB divided by BQ, that is equals to OC divided by CR. When it is possible? When BC is parallel to QR, or when OB divided by BQ, that is equals to OC divided by CR, then BC equals to QR. This is converse of Thales theorem. Okay, so therefore BC is parallel to QR. Reason is converse of Thales theorem. Converse of Thales theorem. Okay, this is the solution of next problem. That is problem number 6. And now I'll go to the next problem. That is question number 7. Using theorem 2.1, prove that the line drawn through the midpoint of one side of a triangle parallel to another side bisect the third side. Okay, for that I'll draw a small diagram here. So what are the given data here? We have to draw one line from the midpoint of one side of the triangle, and that line is parallel to another side of the triangle. Then we have to show it cuts the other side at the midpoint. I'll draw a small diagram. So see here, this is 3.5. I'll consider nearly half, and I will draw one diagram, draw one line. So here I will name the points as A, B, C, D, E, and I will take these two are of equal length. These two are of equal length. So in the question it is asked that prove that a line drawn through the midpoint of one side of a triangle. So D is the midpoint of AB. I will consider one side of the triangle parallel to another side. So here D is parallel to BC. Okay, D is the midpoint of AB and D is parallel to BC. Then it bisects the third side. That means we have to show E is the midpoint of AC. So what are the considered data? Considered data is D is the midpoint of AB and line D is parallel to BC. Now we have to prove E is the midpoint of AC. That means AE equals to EC we have to prove. So when AE equals to EC, that means E is the midpoint of the line AC. First I will consider the given data. In triangle ABC, D is the midpoint. D is the midpoint, and DE is parallel to BC. DE is parallel to BC. So when D is the midpoint, so what happens? AD divided by DB, that is equals to 1. AB divided by DB, that is equals to 1. What is the reason? Since AD, that is equals to DB. So when both the upper value and lower value both are same, then for example upper value is 5 cm and lower value is 5 cm, 5 ones are 5 ones, the answer is 1. So that's why I will consider this. Therefore, by using Thales theorem, in triangle ABC, where DE is parallel to BC, what happens? According to the ratio, AD divided by DB, that is equals to AE divided by EC. AD divided by DB, that is equals to AE divided by EC. So already consider these two, AD is equals to DB, that is as 1. That's why it becomes 1 equals to AE divided by EC. 1 equals to AE divided by EC. Okay, I will call this as equation number 1. I will write here from equation 1. So when we cross multiply, it becomes EC. 1 into EC, it is EC, that is equals to AE. So see the figure, AE equals to EC. So when it possible? So one and only E is the midpoint of AC. Therefore, E is the midpoint of AC. E is the midpoint of line AC. How many of you understood this? Just comment your name. Fast. So everywhere we have used Thales theorem. Then we'll move to the next problem. Okay, look at the steps fast. I'll consider the 8th problem. I'll read the question. Listen carefully. Using theorem 2.2, prove that the line joining the midpoints of any two sides of a triangle is parallel to third side. That is theorem 2.2 means converse of Thales theorem. Okay, prove that the line joining the midpoints of any two sides of a triangle is parallel to third side. For that I will draw a small diagram. I'll consider the endpoints as A, B, C. Here it is given that the line joining the midpoints of the two sides. So therefore, I'll consider here these are the midpoints of these two sides, and I will join that line joining the midpoints of the two sides. I'll give the name as D and E. So this side is equals to this side, that is AD is equals to DB, and AE equals to EC, because D is the midpoint of AB. That means length AD is same as length BD, and E is the midpoint of AC, so that's why AE equals to AC. So I'll write the given data as in triangle ABC, D and E are the midpoints of two sides. Okay, the two sides are, D is the midpoint of AB, that's why I will write first, and E is the midpoint of AC respectively. Okay, so then when this is the midpoint, D is the midpoint of line AB, what it becomes, AD equals to DB, and when E is the midpoint of line AC, then it becomes AE equals to EC. When the two parts are equal, then we can write AD divided by DB, that is equals to 1, because the lengths are same, and AE divided by EC, that is equals to 1. I'll call this as equation number 1, and I'll call this as equation number 2. Here both right hand side are same, so equation 1 is equals to 1, and right hand side, left hand side of equation 2 is also equals to 1. So therefore, comparing equation 1 and equation 2, comparing equation 1 and equation 2, what it becomes, AD divided by DB, that is equals to AE divided by EC. AD divided by DB, that is equals to AE divided by EC. Therefore, when it is, so the two ratios are equal, so therefore the lines are parallel to each other. Therefore, DE is parallel to BC. So by using converse of Thales theorem, How many of you understood this? Just comment your name first. Okay, fast. Then I will move to the next problem. That is question number 9. So in question number 9, it is given that ABCD is a trapezium. Okay, ABCD is a trapezium. Trapezium means one pair of sides are equal to each other, and another pair is parallel to each other, in which AB is parallel to DC, and its diagonals intersect each other at the point O, show that AO by BO, that is equals to CO by DO. That one we have to prove. First I will draw the diagram of the trapezium. That is question number 9. ABCD is on trapezium. A, B, C and D. And ABCD trapezium in which AB is parallel to DC. AB is parallel to DC and its diagonal intersect each other at the point O. So that means we have to draw the diagonal also here. DB is one diagonal and AC is another diagonal, and both will intersect at point O. Show that AO divided by AO divided by BO, that is equals to CO divided by DO. We have to prove. First I will write the given data. ABCD is a trapezium. ABCD is a trapezium. In that AB is parallel to CD. Okay, AB is parallel to CD. This is the given data. And also diagonals AC and BD. AC and BD intersect each other at point O. BD intersects at point O. Intersect at point O. So now to prove the given condition, I will draw a line EO. Okay. Draw line EO where EO is parallel to DC and parallel to AB. EO, I will draw on line EO. For example, see here, this is point E. EO is one line that is parallel to CD as well as that is parallel to AB. In this I will consider triangle DAB. DAB. So this triangle I will consider. Okay. Consider triangle DAB. Consider triangle DAB. In the triangle DAB, EO is parallel to AB. Is correct? Here EO is parallel to AB. So when one line drawn which is parallel to other side, then the other two sides are divided in the same ratio. So that's why it becomes, therefore, according to Thales theorem, what it becomes? DE divided by E. DE divided by EA, that is equals to DO divided by BO, that is equals to DO divided by BO. I will call this as equation number 1. Okay, DE divided by EA, that is equals to DO divided by OB. So then similarly, I'll consider triangle ADC. Triangle ADC. In the first case, I consider triangle ADB. Now I'll consider triangle ADC. Okay, up to now everyone understood? Just comment your name. How many of you understood? Up to equation number 1. Fast. Comment your names fast if you understood. Then I will consider the second triangle. Consider triangle ADC. Consider triangle ADC. In triangle ADC, EO is parallel to CD. EO is parallel to CD. Okay, this is the given. That is by using the construction EO is parallel to DC. So again we have to apply Thales theorem according to Thales theorem. According to Thales theorem, again DE divided by E, or so we consider triangle ADC. Okay, ADC. So therefore I will go from here AE divided by DE, AE, or EA divided by DE, that is equals to AO divided by CO, that is equals to AO divided by CO. See here EA or AE. Okay, EA divided by DE, that is equals to AO divided by CO. Sorry, AE divided by, or EA divided by DE, that is equals to AO divided by CO. I will call this as equation number 2. And then see here DE divided by EA. Here EA divided by DE. So therefore by rearranging this, I will interchange the numerator and denominator value of equation 2. It becomes DE divided by EA, that is equals to CO divided by AO, by rearranging, and I will call this as equation number 3. Okay, so now comparing equation 1 and equation 3. Compare equation 1 and equation 3. DE divided by EA, DE divided by A. So that means left hand side of equation 1, that is same as left hand side of equation 3. So that's why it becomes DO divided by BO, that is equals to CO divided by AO. So it becomes DO divided by BO, that is equals to CO divided by AO. But our requirement is AO divided by BO. AO divided by BO, that is equals to CO divided by DO. Therefore, I will cross multiply this. I will put the AO in the numerator of the left hand side, and I will take the DO on the denominator of the right hand side. That's why it becomes AO divided by BO, that is equals to CO divided by DO. AO divided by BO, that is equals to CO divided by DO. How many of you understood this? This is the solution of the 9th problem. It's a very simple one. Only you have to know how to apply Thales theorem, and also you have to know how to apply converse of Thales theorem. That is very, very important. We just look at the steps. Okay, be careful while solving the problem. Small mistake will lead to the wrong solution. Thank you everyone. I'll continue in the next class.